Joining me now live to discuss is astrophysicist and cosmologist at ANU, Brad Tucker. Brad, good to see you. Looks like Perseverance has done it. How big of a milestone is this?
Yeah, some could say it persevered, right?
Yes.
This was this was one of the big goals, was to collect these rock samples. They've been intending to collect 20 of them. Now, when, as you said, they did it last month and they kind of came up empty, it obviously was disappointing because everything worked well. The drilling, the remote observations. It was when they did that final extraction and kind of shoving it into the tube to store it as a sample, that rock crumbled. So the fact that they got the second one to work, and imagine this: we have this rover on a distant planet. It has to be remotely operated. You're drilling down into a rock. If something goes wrong, it's not like they can fix it because there's a time delay between sending the messages to Earth and it performing that operation, this lag. So you can't fix it if something goes wrong. So everything has to be timed perfectly and work flawlessly. So it's a bit of a disappointment that first time it didn't work. So it's even sweeter success. It looks like that they got this second attempt. And obviously, people will be waiting to see that rock return back to the Earth, as you said, later this decade.
And the rock itself, it's called Rocket. That's its nickname. Why was it chosen specifically?
So this whole area looks to be at the end of essentially a Martian delta. So we know from data and imagery, as we're kind of seeing on our screen, that there's evidence of lots of water flows on the surface of the Mars, that we can see that there was flowing water billions of years ago. And this area they've chosen appears to be a previous delta. And we know deltas usually are rich in water and rich in life here on Earth. So this whole area was chosen to find microbial life. And this rock in particular looks that it was quite immersed in water, that it hadn't been exposed to the surface for too long. Obviously, at the time, it has been since now. But so this was one of these great places to look for a rock that wasn't exposed to the weather, i.e. things could have killed it on the surface, but could have been contained in the rock beneath. So it was kind of this right balance, because the goal here is to get not just 20 samples, but 20 different types of samples from different rocks in different areas, hoping to obviously find this key of life.
Now, on another matter, Brad, NASA's new space telescope, the James Webb, is ready to go.
Yeah, look, this has been a project quite literally almost 2 decades in the making. Now, the James Webb Space Telescope is kind of the successor to the Hubble Space Telescope. This telescope is 6.5 meters wide. So that is the size of the mirror. And what you're actually seeing here is that the mirror will be folded in space. In order to fit in the rocket, they have to fold the mirror, launch it, and then it kind of has to deploy in space. Now, about 18 months ago, as it was going its final testing to make sure everything was working, it would survive the launch, it would work on deployment, they found some last few issues to fix. They've spent the past 1.5 years fixing those issues. About a week or so ago, they finished the last round of testing. Everything worked. So it's been given the all clear to now start being assembled and packaged, essentially, and moved to the launch pad for a launch probably sometime in November. So it's a really exciting time to hopefully see this huge space telescope go up.
Absolutely. It's phenomenal as well how big it is when you scale it next to a human as well, Brad. Now, astronomers have found a new class of exoplanets. What does this mean for researchers' never-ending search for life?
Look, it's quite exciting because, we look at our solar system and we see Earth, and we see that Mars and Venus are similar in Earth. Obviously, the atmospheres are different, but they're about the same size. They're rocky planets with atmospheres. We then look at Jupiter and Saturn, these gas giants. We see Uranus and Neptune, that there's what we call these ice giants. Well, it appears that there is a class of planet we call mini Neptunes, and these fall between kind of Earth and Neptune. So they're a small version of Neptune. But what's exciting about it is that because they're smaller than Neptune, they have more rocky core, so they're more rocky like Earth, but they still have lots of hydrogen. And some of these planets are orbiting their stars in a position where liquid water can exist. So here you have a planet that can be quite abundant in the ingredients for life and in an environment that can keep life alive, essentially, that there's water, that there's not too cold, and that's a bit warm. And the amazing thing about this is that about 20% or so far of all the other star systems we've looked at, all the stars in the nighttime sky, have these mini Neptunes. So this may be the type of planet we should be focusing on to study, to look for life, not just the things like Earth, but these kind of cousins, as it like, of Earth's.
Another exciting development. Brad Tucker, we have to leave it there. Thanks for joining me.
Take care.